Hello everyone, we're going to be finishing up our lecture on Freefall, and we're going to be finishing it up with something that I think you'll find familiar, and that is graphing. Of course, we just had a whole section of graphing last chapter, but I think looking at this now, you'll perceive it as a little bit easier than you might have otherwise. What do we have right here? Well, we've got a velocity versus time graph. So the line on the graph tells us how the velocity of an object is changing. Now we've got a negative slope right here. The slope equals negative, and on a velocity versus time graph, the slope is the acceleration. That's the acceleration. So we've got a negative acceleration, and think about this for a minute. It starts with a positive velocity right here, and then it gets increasingly negative and negative. Right here, that's going to be an important point. The velocity is 0, and now we've got all the way down at the other end, we have a velocity which is negative. And this symbolizes or this represents what we've been talking about the past few days, and that is a body in free fall. So we're asked right here to show the region on the graph where the object is moving upwards. Well, that's wherever the velocity is positive. So we've got a starting velocity of 25, and of course it's getting less and less, but these are still positive down to this point. So everything within this triangle right here, and I'll try to make that line straight, and up, all that is positive or upwards motion. All this shaded area right here. So think of, I don't know, a baseball maybe. It's thrown up in the air. It's thrown up with a velocity, or initial velocity, of 25 meters per second, but gravity continues, the negative acceleration of gravity continues to tug on it and tug on it, and it gets less and less and less high and slower until it reaches 0 right here. Now think about it for a minute. What point is the velocity 0 of an object being thrown up in the air? Well, right here is going to be our maximum height. Maximum height, that's wherever the velocity is 0 or goes from positive to negative, or vice versa. Okay, so it was thrown up in the air here, and it reaches the maximum height, or the velocity 0 right here. And then we're asked, secondly, we're asked, where is the object moving downwards? Well, that's the second part right here, wherever the velocity is negative. So after the maximum height, we've got nothing but negative values here for our velocity. So it must be moving downwards. Oops. So that's going to be our downwards, moving downwards section. So upwards, or upward and downward. And of course right here, like we said before, the maximum height is indicated by a 0 velocity. So what's the object's initial velocity? It's this right here. At 0 time, the velocity is 25 meters per second. And as it's thrown up, gravity makes it less and less and less until it eventually comes back down. So that's kind of the starting of our free fall graphing right here. Let's go on to the next slide. So here we have vertical position versus time. The last one was our velocity versus time. This is vertical position versus time, and this actually kind of looks more like how you picture an object going up. Vertical position is this axis right here, and that kind of makes sense to us because it is up and down, of course. And time is on the x-axis right here. So let's look at this and let's show the region on the above graph where the object is moving upwards. Well, again, you're probably saying, oh, that's easy. It's this first half right here, and you'd be right. This first half all the way up to that point, the object is moving upward. It starts with a a positive velocity, and that positive velocity is whatever that slope of the line happens to be right down there at the bottom. It doesn't necessarily stack with the previous graph, but we might say that the initial velocity is 25 meters per second, although that slope isn't necessarily a slope of 25. But this whole first section right here is where the object is moving upwards. And I think that makes sense. Again, the line is moving upwards. Upward. It should be shaded there too. Well, and right here, that's going to be our maximum height, and it kind of looks like it because it's the top of this arc. Now, we're not talking about objects thrown in parabolas yet. We're simply talking about objects thrown straight up and down, but over time, that would make a parabolic shape. And this is the max height right here. And of course, like you would expect, the slope of that line right there is 0. It's 0. That slope, that horizontal line right at that point is 0. And now the second half of that is where it's moving downwards. This is the downwards part of our trajectory. We've got slope getting more and more negative. And on a position versus time graph, the slope is the velocity. So the velocity is getting more and more negative over time. And of course, we've already illustrated where we have our maximum height right here, downward. All right, let's go on. So looking at the motion of an object in free fall, there's a couple things that we can assume, or that we can at least pick out and say, okay, this is going to be the same every time, and that is the motion is symmetrical around the object's maximum height. Let's go back to the previous slide right here. I'll put my writing back in. You can see the maximum height, if we draw a line straight down, it's symmetrical on both sides. Oops, that's a terrible arrowhead there. It's the same thing. It's not like it goes up slow and then comes down much faster, or goes up fast and comes down slow. It goes up and comes down at the same time, or sorry, at the same rate. And therefore, we can say that the oops, I drew that on the wrong slide. We can say that the graph is symmetrical about the object's maximum height, or about the center, you might say. At the maximum height, the slope is 0. That makes sense to us. We've concluded that already. And at a given height, the slope is equal but opposite. So if we have an object being, oops, come on now, there we go, propelled upwards and coming back down to the same point or to the same level as to say the ground right there, at equal heights, the velocity is going to be the same, just opposite. So if we say this velocity right here equals, I don't know, 10 meters per second, after coming back down, after reaching the maximum height, and coming back down to the same levels before, the velocity would equal negative 10 meters per second. It hits with the same force or same speed, as you might say, as it was propelled upwards originally. So at equal heights, objects have equal speed. And lastly, let's just finish this out right now. We can see that if an object starts at, say, 29.4 meters per second, now there's a reason for that this was picked right here, and that is you can see that every second that goes by, this second, the acceleration is, or sorry, the velocity is decreasing by minus 9.81 meters per second squared. That's 9.81 meters per second less. That's minus 9.81 meters per second less, as is that, and so forth. So we're really seeing a position versus time graph right here, with a velocity that conveniently, this is just for demonstration right here, but that conveniently starts at 29.4 meters per second, and then after a second drops down to 19.6, And after another second, it drops down to 9.81. And another second later, at the very top of its trajectory, we've got our maximum height. And of course, the slope, or the velocity, equals 0. Now, well, not now, but it always has been, the acceleration has been negative or downwards. And so after 1 second, the velocity is going to be minus 9.81 meters per second faster, you might say, or in the opposite direction. And after another second later, the velocity is minus another 9.8, again, negative 19.6. And then minus 29.4 and so forth. So this is a position versus time graph looking at how an object in free fall, the velocity changes over time, and at our maximum height, the velocity is 0. And it's all because the acceleration is negative. This is from point 1 all the way to the very last point. The negative acceleration of negative 9.81 meters per second squared is making the velocity less and less, that is more and more negative, to the tune of minus 9.81 meters per second every second. That's our acceleration of gravity, and this is how we can think about looking at free fall in graph form. That's the end of our lecture. I'll catch you hopefully on some of the example solutions and homework solutions. See you then.